something from exponential form to log form. So these first couple questions here, it's not really a question, it's a true statement. We're just going to convert it from exponential form to a log. So exponential form just means I have an exponent. So 8 squared is 64. You guys know that. So I just want to remind you this real quick. So I can swing this, and the base of my exponent, which would be the 8, becomes the base or the little subscript for the log. When you drag that over to the other side of the equation, it pulls the 2, which was your exponent, down on the level with the rest of the equation, and then this would be log base 8 of 64 would be how you would write that. Kind of the same concept, also true statement, 2 to the negative third power. You can have a negative exponent, totally fine. We're just going to drag that base to the other side of the equal sign, so the negative 3 comes down on the level with the rest of the question, and then you have log base 2. You don't have to use parentheses here, I'm just trying to do that to separate the base from that fraction, but log base 2 of 1/8 is equal to negative 3. Okay, now those are maybe if I gave you those equations and instead of having an exponent I gave you like where the 2's at, if I gave you an x you could solve that. And what we're going to run into today is maybe equations that wouldn't be something we could solve really easily. And you can't do anything other than base 10 on your calculator. So there is a formula to change the base. So I'm going to show that to you guys really quickly. I'm going to do it with variables and then I'll do it with numbers. So this is going to say, and I'm going to use m and b and c here. So these are all positive numbers. You can't take the log of a negative number. Your b value, which is going to be the base for what I'm going to write here, is not allowed to be 1 and it's not allowed to be negative. So I'm going to write the log base b of m. Positive numbers here, b is not equal to 1. You can do what we call change the base to literally any base that you want. And the way you would do that, you'd have log base c, whatever you're choosing your base to be, of m, divided by the log base c of whatever the base was in the original problem. Now, typically what we would choose the base to be would be base 10, because then I could do it on the calculator. So I just wrote this here on the end. Common log, that's what the button on the calculator that says log, it's base 10. So usually when you change the base, you change it to 10 because then we can do it on the calculator. So like, I tell you what, let's just do one of the ones that's right above here. Okay, so let's say I had the log base 2 of 1/8. And I can't type that in my calculator. We could solve that by hand, but if I wanted to use my calculator to help me do this, we could do just log, and if I don't write the subscript, it's implied to be base 10. So I would do the log of 1/8, divide that by the log of 2. And we can use that then to just do this on our calculator real quick. So I'm just going to show you. You already know that's a true statement right there. So your log button, if you guys, we haven't really used it at all yet. It's right next to the 7 on the graphing calculator. On the scientific, it'll just say log is what you're going to look for. But I can just type this in, just do log, and it should pop up some parentheses. So the one thing I want to make sure you do here, make sure you close the parentheses. So log of 1/8, and I'm going to divide that by the log of 2. And then you can see I got negative 3. So that way I can do that on my calculator. So like I said, you could really change the base to anything you want, but typically we're going to change it to base 10 so we can do it on the calculator. All right, is anybody having a question at the moment? Okay, now these are going to ask you to round to the nearest thousandth. There are 3 zeros and 1,000, so that's going to be 3 decimal places. So we were doing these before. I had you guys, and I'm just going to write this so you can see what it means, but I would have you convert it to an exponential. And we'd get rid of the log, base of the log, swing over to the other side, get rid of the word log. That base of the log is going to push that x up in the air to be an exponent. So my answer to this question would be 6 to this power would be equal to 12. You're not going to rewrite 6 and 12 as something to a power and then set the exponents equal. So let's just do the change of base. So all you do to do the change of base, just log of 12 divide by log 6. So it's the log of whatever you're taking the log of divided by the log of the subscript. Important piece here, don't go, oh, that's 12 and 6, and say that's log of 2. It does not work like that, okay? It's two separate logs, so you got to actually type that button twice. So I literally do log 12, make sure you close your parentheses, and then divide by log of 6. And you're going to see, oh, Miss Grody, that's some weird garbage number. Well, if I do, I'm going to hit 6, and I'm going to hit the little caret key. And I don't know if you guys know this or not. Let me zoom out because I use this all the time. If you have an answer, like on a previous line, like I have that right there, this is actually the same button. If you have a TI 30 scientific calculator, it's the same thing. If you hit second, and then I'm going to hit the negative key down here. If you look at the function on that, it says ANS, that stands for answer. I can literally plug in the answer I just had if I want to check that real quick. But you can see if I do 6 to that power, then that's going to be equal to 12. What we're going to ask you that, excuse me, I can't speak this morning. We're going to ask you guys to do is just round to 3 decimal places when you write your answer, because we don't want to write that whole thing out. And it's not going to be something you can convert to a fraction most of the time. So answer to that would be about 1.387. And these are easy to check. And if you want to just check, do like 6 to the 1.387 power. I rounded that a little bit from the actual answer that they gave me in the calculator, so it's a little bit off, but that would be an easy way to check too if you don't want to use that answer button. Is anybody having a question? Okay, so literally just, I want you guys to practice this. See if you can do these. So if you're going to change the base, you're just going to take the log of whatever you're taking the log of, but we're going to do common log, change it to base 10. I'm just not writing the base in because I don't need to for that. And then you divide by the log of the subscript. Again, don't do, oh, 400 is divisible by 5. Don't do that. Just do log of 400, divide by log of 5, and see what you get. Don't forget to close the parentheses. Should be, I'm just going to write approximately equal to, because I'm rounding this, 3.723. Is anybody not getting that or not finding that button on their calculator? What are you going to write for log base 3 of negative 20? No solution. You can't take the log of a negative number. If you tried to do this on your calculator, it would give you an error message. But just remember, it's not defined. Can't take the log of a negative number. Is anybody having a question? Okay, now, here's what we're going to do. We're going to solve some exponential equations, which we've done this before, but I've had you guys make it so both sides were the same number, like base to a power. You're not going to be able to do that here. So what I'm going to have you guys do, I'm going to show you two ways to do this, and you can pick which one you like better. So to get rid of an exponential, we can use a log or we can convert to a log. So for this first question, I'm just going to show you how to convert it to a log. We did that at the very top of the page up there. So I'm just going to show you this real quick. All right, I'm going to take the base of my exponent. You can't like divide by 5. I have 5 to the x equals 16. We got to drag that exponent down or somehow get that exponent to come down. So first option for solving an exponential equation, like these, I'm going to convert this to a logarithm. So base of my exponent, I'm going to drag that across the equal sign. The x would come down on the level with the rest of the question. And I could do base of my exponent being the base of my log. So it would be log base 5 of 16. And then we could do our change of base, just like we were doing in the last couple of questions to get the actual answer. So I would take log of 16 divide by log of 5. Don't forget to close the parentheses. Okay, now I want to give you another option. It's gonna result in us doing the same thing, but I just want to give you another option. The other way you can solve this problem, so I'm just going to rewrite it real quick. is you can actually use log properties. So to get rid of an exponential, it's just like division and multiplication undo each other, addition and subtraction undo each other. If you have an exponential, it's undone by a log. What you can do is take the log of both sides. Okay, now when I do that, if you guys remember from last week, we had the power rule. And so my exponent here, which is where my variable is at, is actually a power, and I now turned that into a log. So I could drag that down in front and write that as x times the log of 5 equals the log of 16. Now, I know this is weird, but the log of 5 is just a number. So I have my variable times that. So to get rid of it, what we would do is we would actually divide both sides by log 5. And you'll see that results in exactly the same thing I ended up doing on the other method. It's totally up to you, but you can convert it to a log, or you can take the log of both sides. Whichever is easier, you end up with the same information that you're going to type into your calculator. So just two options. Okay, does anybody have a preference? Or we don't care? It's a little more writing if you do the log of both sides. I just want you to know you can do both. Okay, so for this next one, I'm just going to convert it to a log. So I'm going to take the 6, swing it to the other side. The 2x, that exponent gets dragged down on the level with the rest of the question. Now, base of your exponent becomes the base of the log, so it'd be log base 6 of 21. Then I get 2x, I'm going to do my change of base, so log of 21 divide by log 6. I'm going to type that in my lovely calculator. Okay, is that the answer to the question? No. Okay, what else do I have to do? You got to get rid of the 2, right? So I just leave it right on the calculator screen. I got to divide by 2 to actually get my answer. So I just did that change of base there. So just literally use your division key, divide by 2, and that should be your answer. And you just go ahead and you don't have to put the 0 in front, but this is about 8.84, actually just 0.85 to 3 decimal places there. And I'm going to have us do one more. So let me I'm going to take the 3, I'm going to drag it to the other side. We've got an exponential. Only way I can get rid of it is to cancel it out with a log. So when I drag this down, we're going to drag that whole exponent down on the level with the rest of the question. It becomes log base 3, 101. And I'm just going to do my change of base. So log, common log, so I can do it on the calculator, of whatever I'm taking the log of, divided by the log of the little subscript, which is your base. So I'm going to do log 101. Don't forget to close your parentheses. Divide by log 3. And then on that question, what would I have to do to get my answer? Subtract the 4, right? So I literally just keep it right on the calculator screen, just minus 4 and 0.201. And you can check any of these in the original problem. You're just going to use your exponent key, and you can plug in your answer, or you can plug in what you rounded. It'll just be a little bit off. Is anybody having a question? Not terrible. Okay, now these two guys on the back are a little bit extra here, more complicated. But what you want to do, exponential equation, we're gonna use a log to help us solve this. Now, first thing on this question, do not multiply that 3 and 5 together. That's a common mistake people make. But what you want to do in each one of these equations that I have up here, a little more complicated, is isolate whatever has your variable in the exponent. So in that first equation there, the only thing that I'm taking to the 2x is the 5. So we want to undo any addition or subtraction first. So get rid of this 9 first. I'm going to add 9. Do not multiply the 3 and 5 together. You're going to end up with 3 times 5 to the 2x equals 120. Just isolating that 5 to the 2x. So don't multiply there. You're going to divide by 3. And that's 40. Okay, now once you're there, You can take the log of both sides, put that 2x down in front, or you can convert it to a log. It's your choice. I'm just going to go ahead and convert this. I don't know why I was grabbing the same exact color. But the base of my exponent is going to swing over to the other side. When you pull that over to the other side, you're going to drag the exponent down on the level with the rest of the equation. And that base of that exponent is 5, so that's going to be log base 5 of 40. Okay, so then we just do change of base real quick. So I'm going to do log of 40 divide by log of 5. And again, don't be like, oh, that's the log of 8. It doesn't work like that. So you have to do log of 40 divide by log 5. And then I didn't leave a lot of room there, but I'm going to take that and divide by 2 because I have my exponent was 2x. So just going to divide by 2 to get my answer. And I'm going to go 3 decimal places, 1.146 here. Is anybody having a question? I don't know why I'm not on the screen there. Okay. So the only thing being taken to the power in this next equation is the 2. So what you want to do, get rid of the 12. So I'm going to do minus 12. So you got negative 4 times 2 to the 3x minus 4. And that's going to be 160. And then I'm going to divide by negative 4. And that's going to be negative 40. Okay, can anybody tell me the answer to this question right now? No solution. Okay, now, I know that real quick. If you kept going, right, we swing this over, and that 3x minus 4 goes down on the level of the rest of the question, we'd have log base 2 of negative 40. You can't take the log of a negative number. So, no solution here. There's nothing that you could plug in for, you got that 2 to the 3x minus 4. There's nothing you can plug in there to make that negative because your exponent can give you a fraction, but it cannot give you a negative number. Is anybody have a question? Okay. Now, at the bottom here, these are going to be similar to some of the problems we did earlier in the unit, but we're going to solve for an exponent here. So these are just going to use that general y equals ab to the x, just a general exponential. So we'll review this a little bit here. So it says currently food truck charges $6.50 for their lunch special. So in your general exponential, a is your initial amount. So that's going to be that $6.50. It says the price increases 4% every year. How long will it take for the cost to be $10? Y is going to be what the cost ends up being. So Y is going to be $10. We're going to find time here. So that's going to be X. That's going to be our variable. My question to you, what are we going to plug in for B? And that's going to be related to the 4%. Do you guys remember how to find the growth or decay factor for your general exponential? Like, what do I do with that 4%? Yes, good. Okay, so if it's most of these give these as a percent. You got to write it as a decimal. So you're just going to take 4 divided by 100, or you could just scooch the decimal place over 2 spots from the 4. So it'd be 0.04. Now, whenever you have decay, it's 1 minus that. We have increasing, so we have growth. So it'd be 1 plus that 0.04. The 1 accounts for what you're already paying for lunch, and the 04 is going to add 4% just right in the same step. So when I set this guy up, oh my goodness, sorry, I just started with the y. I meant to start with 10. So 10, I'm just going to write 6.5. You don't have to use the 0 if you don't want to. And my b value is 1.04 to the x. We're going to determine time here. Okay, most common mistake people make is they will accidentally multiply these two numbers together. Make sure you do not do that. We're going to isolate whatever we're taking to the exponent. So what I want to do here first, I want to divide by 6.5. And I'm going to grab my calculator, and I'm just going to see, I don't think this, if I take 10 divided by 6.5, do you see how that's like a nasty decimal, right? Okay, so here's what I would tell you to do. Just leave it like this, like 10 divided by 6.5, because we don't want to round multiple times as we're doing the problem. All right, now, totally up to you. We can take the log of both sides and then divide by the log of 1.04, or we can convert it to a log, whatever your preference is. But the only way to solve this, we got to use the log to get that exponent out of being an exponent. So I'm just going to drag the 104 down to the other side. So it would be the log, the 1.04 would be the base, and then the 10 divided by 6.5 would be what we're taking the log of if you convert that to log form. If you prefer what I did on the front, oh my gosh, I didn't leave enough space. If you prefer what I did on the front, if you took the log of both sides, you'd have it like this, like log 10 divided by 6.5. That exponent would come down using your log properties. And so it would look like that, and then you would divide by the log of 1.04. So whichever method you like better. So I'm going to take, this will not be a nice number, 10 divided by 6.5. Now, if you are using a scientific calculator, you can't use the fraction key for that because it won't like it if it's a decimal. Just use the division key. And then I'm going to divide that by the log of 1.04. Well, 1.04. Now, this is time. What would you guys, like about how many years would this be? Yeah, I'd say this is going to be about 11 years. It doesn't specifically say what to round to in the question, so however you want to round if it doesn't tell you. Does anybody have a question? Okay. This guy says you bought a car for $15,000, so that's going to be my initial amount for A. Depreciates means I'm going down in value, right? So divide that by 100, so it should be 0.065. And how long will it take the car to be worth $10,500? Now, we're going to want to know when the car is worth that $10,500, so that's going to be your Y. The B value here has to be 1 minus the rate. Like, so how much, we're losing value, but how much value does it hold? So if you subtract that there, should be 0.935. So that's actually pretty good for a car. Usually it depreciates much more than that a year. So it holds just a little bit more than 93% of its value. That's what we're going to plug in for B. We're going to find the time here again. So let me set this up. So we'll have the 10,500, 15,000. Do not multiply this by the 0.935. What you want to do first, you're going to isolate wherever your variable's at. It's going to be in an exponent here because we're solving an exponential equation. So I'm going to isolate that 0.935 to the x. So I actually want to divide by 15,000. Let's see if that's a decent number. Okay, now when I divided that, that's a decent decimal, right? It wasn't this long decimal that went on forever like it was in the last question. So if you get a decent decimal, if you want to use that decent decimal, go for it. So I'm just going to put this as 0.7, 0.935 to the x. Okay, now you can convert to a log. What I'm going to do on this question, I'm going to take the log of both sides just so I can show you guys that other method as well. So if I take the log of both sides, that exponent I'm going to put down in front. So I'm taking the log of both sides, that drags using the power rule. That's going to drag that x down in front. And then what you would do to solve, that log 0.935 is just some weird number times your variable that you're trying to get. So if you're multiplying, we're going to divide to get rid of it. Same look as your change of base. Same math there, just a little different way to do it. So log 0.7 divided by, don't do it like I just did it. Make sure you close your parentheses in between there. And then I'm going to say about, I don't know, 5 point, whatever you want to round to. It doesn't specify here. I'm going to go 5.037 just to kind of be consistent with what I had on the front, because that wasn't really close to something like it was in the last problem. Is anybody having a question? Okay, so we did an increase, we did a decrease, and now I'm going to just remind you guys of the little half-life formula, and then we'll be done. So the half-life formula is just slightly different. Y equals A. Now, whenever you're working with the half-life problem, you won't have to figure out the B value because the B value has to be a half. Yes. Now, the exponent is a teeny tiny bit more complicated with the half-life. It's still time, which is represented typically with an X, but you have to divide that by whatever the half-life is for your exponent. So this will have an extra step the other questions didn't have because we'll have to multiply by whatever the half-life is. Okay, so now it gives me the half-life of a substance is the 2.45 hours. So I'm going to plug in for half-life the 2.45. You have 100 milligrams of the substance. So that's going to be your A value. About how long will it take you to have 75 milligrams? So why I want to know when this is going to, it's not going to be a complete half-life, right? Because half would be 50. So it's going to be less than a half-life. We're going to plug this information in and solve for X. 75 equals 100 times 0.5 X over, I do know the half-life is 2.45. Do not multiply the 100 by that 0.5. That's the most common mistake I see people make. So I'm going to divide by 100 here. So I'm going to take 0.75. That's a decent decimal. I'm not rounding anything. 0.5 to the X over 2.45. All right, and just doing a little variety here. What I'm going to do, I'm going to take the log of both sides. Log is the only way you can get rid of your variable being an exponential. And I'm going to write it out because I have a little bit more space here. But we had the 0.5 to that power. That power rule allows us to drag that down in front. So we'd have that log of 0.75 equals X over 2.45. So it'd be like a little fraction multiplied by the log 0.5. Now, just remember, log of 0.5 is some weird number. So we're multiplying that by the fraction where our variable's at. I'm just going to divide by that log of 0.5, which is essentially doing a change of base. Now, when I do this, I'm going to keep this right on the calculator screen because these are not going to be nice numbers. So log 0.75 divided by log 0.5, that would be equal to the X over 2.45. So just going to do it right on the calculator screen. I'm dividing my time by 2.45, so I have to multiply by 2.45 to get that out of that denominator. So then this is going to be just a little bit more than an hour, so like 1.017. Your answer will be in whatever units that your half-life is in. So it gave us the half-life in hours, so my answer is in hours. Is anybody having a question?